Welcome to the video lecture series of Grade 10 Physics. Today I am going to explain the lesson Electricity and the topic is Resistors in parallel. How resistors can be connected in parallel? Is there any difference when current is passing through this resistor? Okay, so we are going to explain this resistors in parallel by considering this diagram. When you look at this diagram, you can see three resistors R1, R2 and 3 are connected. So all these three resistors are connected parallel to each other, and these three resistors are connected to another electrical circuit. And then one voltmeter is attached over here, which means it is measuring the potential difference PD, and also an ammeter is connected. It is measuring the amount of current, how much current is passing through the circuit. Okay, so when, for example, if 6 ampere current is passing through this entire circuit, but when it is reaches to this resistors, there are two connection joining points over here, that is X and Y. And again the first resistor is R1 and there is another resistor R2 and then the third one is R3. So this entire current is dividing when it reaches to these three resistors, which means the current is dividing in a parallel connection. But the potential difference, for example, if it is 5 volt, but it will be same in the parallel connection. So the important point you need to note that potential difference will always be same in a parallel connection, but current will be dividing between these three resistors. So the first resistor will have some current and second resistor will have another current and third one will have the another amount of current, which means the entire current passing through the circuit is dividing into these three resistors. So total current I is equal to the sum of the separate current through each branch of the combination. So the total current I is equal to I1 plus I2 plus I3. I1 is the current of the resistor R1, I2 is the current of the resistor R2 and I3 is the current of the resistor R3. Okay. So R1 will have the current I1 and R2 will have the current I2 and R3 will have the current I3. Now, by applying Ohm's law, we have another equation that we already studied. I is equal to V by R. Current is equal to voltage, potential difference. Voltage means potential difference divided by resistance. So I see this I, we are dividing into three current. So I1, I2, I3. So accordingly, we can write the equation I1 is equal to V by R1 and I2 is equal to V by R2 and I3 is equal to V by R3. When you look at this equation, you can see the V is constant over here, which means the potential difference is constant. Okay, and the current is varying with respect to the resistors. Now, so when you apply this equation into V by Rp, you will get V by Rp is equal to V by R1 plus V by R2 plus V by R3. Okay, and current is common, which means it is connected to three resistors. So the entire current is divided into three individual currents. So V is the potential difference that is common to the, that is common means it is constant for the entire circuit. So V by Rp will be writing like 1 by Rp. We can cancel V here, second one, third one and the fourth one. We are cancelling all the potential differences because it's common to all the current. So we have cancelled the V in the entire equation. So we'll get the equation as 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equation, or this is the formula to calculate the equivalent resistance or total resistance of the parallel connection. Here Rp represents the total resistance or equivalent resistance, or we can say equivalent resistance. Equivalent resistance of the conductor, total resistance of the conductor in parallel connection. P represent parallel connection. Okay, so 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Why we have written R1, R2, R3? Because we have connected here three resistors. In the circuit, if we have two resistors only, so that you need to use only 1 by R1 and 1 by R2. Okay, so this equation will be varying according to the number of resistors connected. Now, so what is the important point you need to note from this equation? How to calculate the total resistance in a circuit in parallel connection. Another thing you have to note that I will be varying. Then what about V? V will be same. Same means it will be constant, which means if it is 5 volt, the entire circuit will have 5 volt. But the current will be dividing through the different resistors. Okay, so I will be varying, but by the time V will be constant or same. Now we can solve one equation using this formula, and this is a problem. Calculate the total resistance for two 180 ohm resistors connected in parallel. So the connection is parallel connection, and you have to calculate the total resistance. So total resistance means Rp. You have to calculate. R represents the resistance and P is used for parallel connection. So Rp, which means the total resistance, is equal to how much that we wanted to calculate. Then we have two 180 resistors, 180 ohm resistors, which means there are two resistors connected in the circuit. One is R1 and another one is R2, and both are having the resistance 180 ohms. So 180 ohms. Okay. So we have to calculate the total resistance for two 180 ohm resistors connected in parallel. So you already know the equation. 1 by Rp is equal to 1 by R1 plus 1 by R2. Okay, how do we calculate this one? So 1 by 80, both are having same resistance. So 1 by 80 plus 1 by 80, which is equal to 2 by 180. So 1 by 180 plus 1 by 180 is 2 by 180. And if you simplify this, you will get 1 by 90. So that is 1 by 90. So therefore we can conclude in this way. 1 by Rp is equal to 1 by 90. 1 by 90. So therefore Rp, total resistance in parallel connection, is equal to, we need to take the reverse value. So which means it is 90 ohm. Now the second problem. In the circuit, okay, three resistors receive the same amount of voltage, 24 volts, from a single source. Calculate the current through each resistor and also find the equivalent resistance. So in the question, it's given three resistors receive the same amount of voltage, which means potential difference. Voltage is same. So V is equal to 24 volt for the entire circuit. Okay. There are three resistors here. So we can take it as R1, R2 and R3. There are three resistors connected for the entire circuit, and V is equal to 24 volt from a single source. Then calculate the current through which each resistor. So we need to calculate current through each resistor. As R1 will have one current I1. So R1 here it is 1 ohm. So it will have one current V1 that we need to calculate. Then R2 is 2 ohm. Okay. So its current will be V2. And R3 is 3 ohm. Its current will be V3. So these three individual current we need to calculate. And also find the equivalent resistance. Equivalent resistance you already know, that is Rp also we have to calculate. So V1 we have to calculate, V2 and V3. Okay. So these are the data given. Then, so total current you already know, I is equal to I1 plus I2 plus I3. Now, we can calculate the equivalent resistance or the total resistance in the parallel circuit. We can calculate first. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. Now 1 by R1. R1 is 1, so 1 by 1 plus R2 is 2, so it is 1 by 2. R3 is 3, so it is 1 by 3. So total it will be coming in this way. You have to take the LCM. So 1 into 2 into 3, the LCM coming like 6. Okay, and when you solve 1 by 1 into 6, 6 into 1 by 1, you will get 6 itself plus 6 into 1 by 2. So you will get 3 plus 6 into 1 by 3. So it will be coming like 2. So it will be 2. 6 plus 3 plus 2 divided by 6, which is 9 plus 12, that is 11 by 6. So 1 by Rp is equal to 11 by 6. Therefore Rp is equal to 6 by 11. If you further solve this equation, you will get 0.54 ohms. So the equivalent resistance or total resistance through the conductor is 0.54 ohm. Now next is we need to calculate the current through each resistor. That is second part of this question. Okay, so we are going to calculate V1, V2 and V3. So individual current, we have the expression V is equal to I into R. That is the Ohm's law, which means I1 into R1. Okay, therefore I1 is equal to V by R1. Okay, so similarly I2 is equal to V by R2 and I3 is equal to V by R3. Okay, now V is constant value, V is equal to 24 and R1 is equal to 1, which means 24 by 1 equal to 24 itself, that much amperes. Now for the second one, I2 is equal to V by R2. V is again constant. What is R2? R2 is 2. So 24 by 2, that will be giving like 12 amperes. And what is V by R3? V is 24 again and R3 is 3. So 24 by 3 will give you 8 amperes. Okay.